and welcome to our presentation about MultiLegalPile, a 689 gigabytes multilingual legal corpus. This is joint work with Veton Matoshi, Matthias Stürmer, Ilias Chalkidis, and Dan Ho. Justice systems are horribly overwhelmed, and this all over the world. For example, immigration courts are backlogged in the US. In the UK, the family court system is overwhelmed, but also in France, Germany, Switzerland, India, and Brazil, the judiciary system is overwhelmed completely. As you know, LLMs are amazing at many things. I don't have to tell you that. But they still make many mistakes, especially in the legal domain. For example, you may be familiar with these two cases where lawyers used ChatGPT to save time, but then got fired or fined. So, why is reasoning over legal text so difficult? First, legal text is complicated. We call it legalese even. It's usually very long, as illustrated by these terms of service documents on the right. You may need legal knowledge to understand it, so relevant legislation, case law, or legal analysis. And it is different in each jurisdiction. So unlike computer science or medicine, the law is different in different places where you go. So why did we create the MultiLegalPile? As you know, LLMs need huge amounts of pre-training data. So far, however, most corpora are English only or predominantly based on web crawls. So high-quality, multilingual, domain-specific corpora are rare. And we fix this issue with the MultiLegalPile. We create a multilingual and legal domain-specific corpus. The MultiLegalPile contains 4 parts. First, EURLEX resources, around almost 180 gigabytes. This contains case law, decisions, directives, and so on, and is available in all the 24 EU languages and has been scraped from the EURLEX database. Second, we have the native MultiLegalPile, around 110 gigabytes, and there we scraped national case law and legislation in 14 EU languages from various countries. Then we filtered the MC4 dataset, so internet text, by using legal citations in the 24 EU languages to get legal text. And this gave us another 100 gigabytes roughly. And finally, we integrated a large existing legal dataset, the Pile of Law by Henderson et al., which contains case law, legislation, legal analysis, and so on, in English, but predominantly from the US. So, how is this data distributed across text types? So, first we have the MC4, so the legal parts of internet text. Then second, we have legislation. We have contracts. These are a bit underrepresented because most contracts are private inside businesses, so it's hard to scrape them. And the largest part is being made up by case law. And then we have also some other text grouped in this category. How is it distributed across languages? So you can see here that English still makes up the largest part of this corpus with 44 billion words, but this distribution would look very different in many other pre-training corpora. And here we have many texts from other languages as well. And by covering the 24 EU languages, we cover 2 times more total speakers. So we go from 1.5 billion English speakers to 3 billion speakers. and we quadruple the native speakers covered. So we go from 380 million to 1.5 billion. Then we trained multilingual legal models. So what we did was we warm started from the XLM Roberta models and continued pre-training. And here you can see the specs. So we continued pre-training both the base and the large size. We made the vocabulary a bit smaller. So we only covered 24 languages. So we can get rid of many tokens in languages that we don't cover. But then we create a little bit of a bigger vocabulary for the languages covered. In total, we train the models for 1 million steps, the base size models, and the large size models for 500,000 steps. We also train monolingual models. We train the base models for 200,000 steps and the large ones for 500,000 steps. Also note the smaller vocabulary size here. Then we evaluated our models on the LegStream benchmark, which is a legal reasoning benchmark covering 24 EU languages. If we look at the results here, we see that our legal models outperform the even the largest domain agnostic or general language model here that was available at the time of evaluation. Here it must be noted that we aggregate multiple times. So each column you can see here corresponds to one data set. And some of these data sets are available in many languages. And they may also have different tasks inside that are available in many languages. So we first aggregate over the languages inside the task and then over the tasks. And finally, we have the dataset aggregate score for each of the datasets. And we can see that the long-former model performs best here, especially for single label text classification tasks, as these 4 tasks are. The long-former model is the state of the art for all of them. We see that in named entity recognition tasks such as these here, the performance is not as high, or we see that the performance seems to be saturated much more, since the difference between the worst performing model and the best performing model is quite small in comparison. Then we also evaluated them across languages. So here we can see that the general model performs best, and our legal models are close seconds. The long-former model is not as robust across languages, as we can see here. Surprisingly, monolingual models perform very well here as well. For example, in Hungarian, in Croatian, or in Latvian, or also in other languages, the monolingual models perform best even. We also evaluated on an English legal benchmark, and we see that our large model is the new state of the art here, outperforming all previous evaluated models. And especially on these 4 or 5 tasks here, we see that we set a new state of the art. Again, in LETCAR or unfair terms of service, the difference is a bit smaller, and this gives us some indication that these tasks may be saturated. To conclude, we created a 689 gigabyte multilingual legal corpus, pre-trained 2 multilingual, a long-former, and 24 monolingual models, and set new state-of-the-art on the LegStream and LegSglue benchmarks. Everything is available on Hugging Face and GitHub. You can freely use it and download it. We made it available on the most permissive licenses possible. In the future, we would like to continue pre-training larger generative models to see what we can achieve there. Thanks so much.